So in this case, again, guys, when I'm provided a triangle, the first thing, Hunter, that I look for is, do I have a ratio? If I have a ratio, I know I can use the law of sines, because we are going to use the law of cosines next class period. So look for the ratio. If you have a ratio, automatically think law of sines. And we have a ratio right here, right? So I say 4 over the sine of 25 degrees. Then we say, well, what do we want to set that equal to? Do we want to set it equal to the ratio for A or the ratio for B? Well, since we have the sine length of A, I'll set up to a ratio of A. Okay. Now, automatically notice I have a triangle with a acute angle, right? So as I remembered, when I only have an angle, or when I have a triangle with one acute angle, I have to check for 2 cases. Yes, Maggie?
Why can't you say that it's 6.2?
Oh, yeah, it is. I just didn't write it in yet. OK? So for all times, middle bin, every single time you have this with one single acute angle, you have to check for your 2 cases. So I go ahead and solve for this. So I have sine of A equals 6.2 times the sine of 25 degrees all over 4. OK? So now I plug this in. And in this case, we have 6.2 times the sine of 25 divided by 4. I take the inverse sine of my second answer, and I get 40.92. Now, remember, ladies and gentlemen, as I mentioned, how do you check for the other case? Well, remember, when we look at this, here's 40.92 degrees. But the other angle that has the exact same sine value is a direct reflection of that, right? So how do we find that? 180 minus 40.92, right? So it'd be, I have 5 minutes, 39.08. So I have now, let's go and check. Kobe, in the last example, let's take that out. In the last example, we had, when we added up that ambiguous case, when we added up that extra angle, it was over 180, right? But when I add up 139.08 plus 25, is it possible that that angle could be 139 as well? Yes. So guess what? Now I have to include 2 cases. Or this could be 139.08. So now I have 2 cases. All right? So what I'd like to do is set them up. So now this could be 40.92 or 139.08. Now, the last thing we need to do is be able to figure out what C is, right? So what we could do is, let's draw now 2 different triangles for 2 different cases. If this is what my triangle looks like, to be able to find the angle C, Mackenzie, right now I'd just be taking a look at this. What I would do is I'd say 180 minus 25 minus 40.92. And I could say C is going to be 114.08. OK? Then the next case is, what about if A was 139 degrees? We're doing 2 cases. I'm saying one when A is 40.92, and the other case when A is 139. So what I do now is I say 180 minus 139.08 minus 25. And that gives me an angle of 15.92. And I still don't know C. And B is 4. OK? Does everybody see what I did? I took the two cases, and I created two triangles. Again, I'll go up to this. Once I found the two angles, Caroline, it's either one of these two. A could either be one of these two angles. So what I did is I drew two separate triangles, because now I need to find my length of C. So to do that, I say sine of C over 25 equals, and you can use A or B. I'll use my A, which would be sine of 40.92 over 6.2. Over here, I need to find, again, for a C, so I can say I don't know what C is. Sorry. It's sine of 114.08 over C is the same as sine of 40.92 over 6.2. And then here, again, I can take sine of 15.92 over C equals, again, I'll do the same thing, of sine of 1/3. It doesn't matter. Yeah. OK. So then I'll just go and solve the answers, I guess, and we'll let class run out from there.